Assalamu alaikum wa rahmatullahi wa barakatuhu. This is the chapter number 19, Matrices and Determinants, exercises 19.2. In this video, we will learn how to find the inverse of 3 by 3 matrix. Okay. So the question is A is equals to 3 by 3 matrix is given over there. Then we have to find the A inverse. As we know that A inverse equals to 1 upon determinant of A multiplied by the joint of A. So first of all, we have to find the determinant of A. So just we will read the step number 1. We will check whether the given matrix is invertible, means or non-singular. For this, we need to find the determinant of given matrix. If determinant will not be equals to 0, then it will be the invertible or non-singular matrix, then the inverse will exist. Okay. So we will check whether we are getting 0 or not by finding its determinant. So finding determinants of matrix A is we have written the matrix A into the determinant form. Okay. Then for finding the determinant of 3 by 3 matrix, we have to work on we have to consider only the elements of the row. Okay. Means 1, 4 and 2 we will consider. So how we need to write? We will write the very first element, that is 1, right over there. Then multiply it by its corresponding minor or corresponding 2 by 2 determinants. What it will be? Just we need to write 1, then consider or just eliminate its corresponding elements of row and corresponding elements of column. So what will we have? We will have 0, 9 and 2 minus 3 in the determinant. Okay. Then here the negative sign will come, and then the second element is 4. You have to write here 4. This will be multiplied by its corresponding 2 by 2 determinant. How it will be formed? We will just eliminate this row and this column, or just corresponding element will be of row will be eliminating and corresponding elements of column will be eliminating. So the remaining elements mean 7, 9 and 0 minus 3 will form the determinant. Okay. Now just put the positive sign, then write the third element, that is 2, and this will be multiplied by its corresponding 2 by 2 determinant, and we need to eliminate this row and this column. So 7002 will form this determinant. Now just calculate it. 1 will be multiplied by 0 minus 3 is 0, minus 9 2 is 18, minus 4 7 minus 3 is minus 21, and then 90 is 0. Then plus 2 and 7 2 is 14, and minus 0 is 0. Okay. Then after calculation, we will find this is the 94, and 94 is not equals to 0. That means this is invertible or non-singular matrix. That means inverse exists. Okay. So we will move towards the next step. Step number 2 is we have to calculate the cofactors of this given matrix. For finding the cofactors, we have to calculate the determinant of 2 by 2 minor matrix, and this A, its formula is Aij is equals to minus 1 raised to power I plus j multiplied by minor of Ij. Okay. I and j stands for number of row and number of column. Okay. Then we will put one by one the elements in this formula. So first of all, we will find the cofactors of row 1. We need to in fact find, there are 9 elements, so we have to find the 9 cofactors. Okay. So cofactors of row 1, how we will find? The very first its element is 1. Okay, then how we will find it? Just you have to write A11, that is equals to minus 1 raised to power 1 plus 1. Here from the formula, you have to just observe this formula, and you have to write its power 1 plus 1, then it will be multiplied by its minor. Okay, how it will be multiplied by the minor? How the minor will be formed means we have to just, this is the first row, first column element, so we need to delete the first row and first column. So 0, 9, 2 and minus 3 will form the determinant. Then minus 1 raised to power 2 means that is the positive sign will come over there, and 0 minus 3 is 0, minus 9 2 is 18, so minus 18 is the first cofactor. Now we will find the second cofactor, means the first row and second column. So first row and second column, that is equals to minus 1 raised to power 1 plus 2, and then the determinant will be formed containing the elements by eliminating first row and second column elements. Means we have to eliminate first row and second column. So 790 minus 3 will form the determinant. Okay. So minus 1 raised to power 3 will give us the negative sign. Then 7 minus 3 is minus 21, minus 90 is 0. So minus 21 will be multiplied by minus, so it will give us positive 21. Okay. Then we have to find the third cofactor, means first row and third column. First row, third column, that is equals to minus 1 raised to power 1 plus 3. And determinant, we will just eliminate the first row, third column. 7002 will form the minor, and then minus 3 minus 1 raised to power 4 will give us positive sign. 72 is 14 minus 0, that is equals to 14. So we have found here all the cofactors of row 1. Okay. Now, just moving towards finding the cofactors of row 2. I have written here down the again matrix. Now we are considering the focusing on the second row. Okay. Now second row, first column, we have to just eliminate for finding its minor. Cofactor to 1 is equals to minus 1 raised to power 2 plus 1, and eliminate second row and first column. So 4 2 0 4 2 2 minus 3 will form its minor, and minus 1 raised to power 3 means negative sign will appear over there. 4 minus 3 is minus 12, minus 4 to 2 is 4. So minus 16 multiplied by minus, so it will give us positive 16. Similarly, we will find A22 and then A23. Okay. And then again, we will find the cofactors of third row. This is the cofactor of third row, A31, and then A32, and then A33. Okay, so all 9 cofactors we have found. Now we have to move here on the step number 3. Step number 3 is we have to formulate the cofactors matrix. Okay, so cofactor matrix, how we will find? That is equals to a joint of A is equals to cofactor of matrix. We have to write, and then we have to put here its transpose sign. So we will write all cofactors, first row cofactors, then second row cofactors, and third row cofactors are shown here. 36, 5 and minus 28 we have written here. Okay. And now the next step will be we have to find its transpose. So step 4 is find the adjoint of matrix by taking the transpose of the cofactor matrix. So transpose is we have to just only change the elements of row into the columns, or number of rows into number of columns. Okay, minus 18 to minus 18, 21 and 14. This is row elements will be changed into column minus 18, 21, 14. Here 16 minus 3 and minus 2 will come in this column. 16 minus 3 and minus 2, then 36, 5 and minus 26 feet. So we have found the adjoint of A. Now in the next step, here adjoint of A is written again. Now the last step is we have to insert the result in the inverse matrix formula, that is A inverse equals to 1 upon determinant of A is multiplied by adjoint of A. So insert its values. 1 upon mod A means 1 upon 94 multiplied by this matrix as we have formed by taking the cofactors. Okay, so 94 will be divided by each element of this matrix we have shown over there, and then after simplification we will get A inverse that is equals to this uh, matrix. So this is our answer. Okay, Jazakallah.